Welcome back, guys. Today we're going to be looking at topic 5.2 for systems of equations. And today we're going to be looking at the types of solutions and the number of solutions that we can have when we're looking at a linear system of equations. So up to this point, we have looked at what a linear system is. Ultimately, a linear system is two or more equations that have a common solution. And so when we're graphing on a grid, that's going to be where we see our intersection point. And so up until this point, most of the questions that you've been working with have one solution, but let's see if there's some others. All right, so when we're looking at a linear system of equations, there are three different solutions that we can get. So we can either have intersecting lines, no intersecting lines, or coincidental lines where both equations look identical or both graphs look identical. So the first question is the one that we've been dealing with the most right now. So there's one solution there, one intersection point, and that's our solution. These are called intersecting lines. And intersecting lines have one solution. Now, one key standout if we're looking to see if something has one solution or not is that these two lines will have different slopes. So as soon as you look at your equations, if they have different slopes, then that should be the indicator that they are intersecting lines or there's going to be one solution. Now, the next type of system that we can have is parallel lines. And if you remember from our linear functions unit, parallel lines means they have the same slope. And the same slope means they never intersect, so there is no solution. So parallel lines will have the same slope and they never intersect, so there's no solution. Now it's important to note when you're graphing on your calculator, sometimes you're going to be graphing two lines that look parallel but they're not, or they are parallel and they don't look, and it just has to do with the distortion on the grid. So the only way to be sure is to actually look at your equation and ask yourself if your slopes are the same or not. Now the last type is called coincidental lines. And I always think about this one as a coincidence. It is not very common to see the two lines on top of each other like that, so it's a coincidence that they end up being identical. Now, if something is coincidental, that means it has infinite solutions because one graph is lying right on top of the other graph, and so there's going to be infinite solutions because every single part of one graph is touching the other graph. So infinite number of solutions. Now, the way that we know that something is coincidental, it has to have the same slope and the same y-intercept. Because if it's coincidental, it means it's sharing everything in common. But looking at equation, we're looking for the same slope and the same y-intercept. Now, if you're being asked to determine how many solutions there are or what types of solutions there are, you don't have to solve the entire equation. You can determine if it's intersecting, parallel, or coincidental just by looking for those key features. Different slopes, and then same slope and same y-intercept. So let's take a look at three examples here. So example number 1 says, predict the number of solutions and state the types of lines without solving for each of the following systems. So we're being asked for the number of solutions. So our choices are going to be 0, 1, or infinite. Some people will draw the infinity symbol. And state the types of lines. So types of lines, we're going to either have intersecting, parallel, or coincidental. So the first one here, the best way to know if these lines are intersecting, perpendicular, or coincidental is to rearrange them and write them as y equals mx plus b. So the first one is going to be y equals negative 3x plus 9. The second equation, we're going to have 2y equals negative 6x plus 6. And when we divide by 2, we have y equals negative 3x plus 3. So comparing these graphs, they have the same slope, but different y-intercepts. So if these have the same slope, that means these lines are parallel, but they have different y-intercepts, so that means there's no solution. Okay. If they had the same slope and the same y-intercept, then they would be coincidental. All right, let's take a look at example B. So the first equation, y equals negative 3x plus 9. And example 2, we've got 2y equals negative 6x plus 18. We're going to divide by 2. And y equals negative 3x plus 9. If you notice, these are identical graphs. And the equations are identical. That means these are coincidental lines. And if they're coincidental, that means they have infinite solutions. All right, last example here. We've got y equals 4x minus 3 and y equals 1/4 x plus 3. Well, there's no manipulation needed here. I can already look right away and see that these are different slopes. So I don't have to look any further than that. Different slopes means that these are intersecting lines. And that means there's one solution. Now, some students will mix up the whole idea of negative reciprocals when we're thinking about perpendicular and intersection points. They do not have to be opposite signs to be intersecting lines. They just have to be different. All right, let's take a look at 4 more examples here. So example number 2 says, predict the number of solutions and state the types of lines without solving for each of the following systems. So this might be a time where you want to pause the video, try them on your own, and then come on back. But we're going to go through them here right away. All right, so for the first example here, we've got 6x plus 2y equals 12. And so if I start to manipulate my equation here, for equation number 1, I'm going to have 2y equals negative 6x plus 12. Divide by 2. Y gives me negative 3x plus 6. And equation number 2 is y equals negative 3x plus 2. So looking at this, they have the same slope, but different y-intercepts. So I'm going to say that this one is parallel. And parallel means no solution. Let's taking a look at the second one here. Equation number 1, we're going to divide everything by 3. So y equals 4x plus 3. And if you notice, that's exactly the same as the second equation. So these are going to be coincidental. And coincidental means infinite solutions. All right, question part 3 here. Equation 1, we've got y equals 2x. And then we've got y equals negative 1/2 x. We don't actually have to do any calculations here. They're different slopes. And different slopes means that these are intersecting lines, and intersecting lines means one solution. All right, let's take a look at the last one here. We've got y equals 3x plus 1, y equals 1/3 x plus 2. Again, different slopes and intersecting lines. All right, now let's check our answers here. We've got parallel, no solution, infinite solutions, coincidental, one solution, meaning intersecting lines, and one solution, intersecting lines. All right, that's it for the lesson today. I hope you had enough examples there to help you out, and we'll see you soon. Have a good day.